for this video is power theorem. The first property is 2 secant power theorem. This property states that if 2 secant segments shares the same endpoint outside the circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. So in this circle, we have here 2 secant segment that share same endpoint outside the circle. So we will use property number 1. So we have here the values of line segment A, C, and D. We need to find the value of line segment B. So we will substitute the given values. A, 4 times 4 plus B is equal to C is 5 multiply to 5 plus 3. So 4 times 4, 16 plus 4B equals 5 times 5, 25 plus 5 times 3, 15. So we have here 25 plus 15 is 40. 16 plus 4B. So, this will become 4B is equal to 40 minus 16. So, 40 minus 16 is 24. 4B. Divide both sides by 4. Our B is equal to 6. Next, property number 2, tangent secant power theorem. This property states that if a secant segment and a tangent segment share an endpoint outside the circle, then the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent segment. For example, in this circle, we have a tangent segment and a secant segment that shares an endpoint outside the circle. So we will use property number 2. So we have here the values of line segment B and C. Now, we need to find the value of line segment A. We will now substitute. So, A squared is equal to B is 2 multiplied to 2 plus C is 6. So, A squared is equals to 2 times 2 plus 6, 8. A squared is equals to 8 times 2 is 16. So, to cancel squared, we will get the square root of 16. So, A is equal to square root of 16 is 4. Property number 3, two-chord power theorem. This property states that if two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So in this circle, we have here two chords that intersect in one point inside the circle. So that means line segment A times line segment B is equal to line segment C times line segment D. So we have here the measurements of line segment A, C, and D. We need to find the measure of line segment B. So we will substitute the measurements. So A is 6 multiplied to B equals 3 multiplied to 4. So 6B is equal to 3 times 4, 12. Divide both sides by 6. Cancel this out. B is equal to 2. That means the measure of line segment B is equals to 2. Okay, to check it, 6 times 2 is 12. 3 times 4 is 12. That means the answer is correct.